Hello everybody. In this video, I hope to provide you with a good understanding of what a composition of functions really is. We will look at a basic example and the domain of the composition. And in another video, we'll look at a more complicated example and the domain there. So here we're starting with two polynomial functions, f of x and g of x, and we want to find the composition f of g of x. A composition of functions is sort of like nesting dolls. I don't know if you've seen these before, but this is a nesting doll. Say this is the function g of x, and we want to place it inside of the function named f of x. And so we end up with the composition of the function. So here we go. I want to find first f of g of x. We might be better off using this notation, f of g of x. I like this notation because it clearly shows that the function g of x is going to be placed inside the function named f of x. So we find the function named f of x, we leave a gap, and inside that gap we place the function named g of x, 2x squared minus 1. Then we simplify. We get 6x squared minus 3 plus 2, which gives us 6x squared minus 1. So that is f of g of x. Okay, now we need to find g of f of x. G of f of x. Again, I prefer to use this notation because it clearly indicates that we're going to take the function named f of x, find the x in g of x, and insert it in place of x. So here's the function named g of x, and I will leave a gap for f of x. Of course, that gap needs to be squared. And inside, I'm going to write what f of x is, 3x plus 2. And I'm going to simplify. All right, we'll need to square this binomial. You can use the FOIL method or this quick method. Square the first term, first times second, and double the result. Then square the last term, bring down minus 1. Now, distributing, I have 18x squared plus 24x plus 8 minus 1. And my answer is 18x squared plus 24x plus 7. That is g of f of x. Okay, now what would happen if we were to find f of x? Well, we would find the function named f of x, and wherever we see the x, we would place the function f of x. So I'm going to write f of x and leave my gap to place in f of x, and then place it in. Distributing, I have 9x plus 6 plus 2 is equal to 9x plus 8. And that is f of x. Now, what if we wanted to find f of g of 2? We want to find f of g of 2. In other words, we can use this notation, f of g of 2. Well, there are two ways to do this. The first way is to actually plug in 2 into the rule we just got for f of g of x. So where we see this x here, we're going to plug in a 2. So we have 6 times 2 squared minus 1. And again, that's f of g of 2. So we have 6 times 4 minus 1, which is 24 minus 1, or 23. But depending on the context of the problem, sometimes it's easier to use this other method, we could actually plug in 2 into the function named g, get the answer, and then plug that result into the function named f. So let's try that. I'm going to plug a 2 into the function named g. So g of 2 is 2 times 2 squared minus 1, which is 8 minus 1, which is 7. Okay, so that's what I got for g of 2. Now I'm going to take that 7 and put it inside of x. So we take f of 7, and that gives us 3 times 7 plus 2, which is 21 plus 2, which is 23. Hey, we get the same thing. Yay, they're the same. So that is how we find f of g of 2. Now, the domain for all of the compositions we have done in this problem would be the set of real numbers. Why? Because all polynomials have as their domain the set of real numbers. Now, we will go into that more and look at some different functions to find a composition in the next video. Thank you for watching. I hope this helped you. If it did, please like and subscribe.